Materials are technology enablers. If you want to build new cars, new planes, new energy devices, renewable energy instruments, you need better materials to improve their properties, to improve their efficiencies, to improve their functionalities. And it's our task as material scientists to develop these new materials, to improve existing materials, and to make them ready for their applications. We have to consider the whole life cycle of materials. That's also one of our duties. How do they age in their use? How can they form defects? How do they fail? Think about an airplane, for example, where you do not want to have any failures. And we have to characterize and develop these materials so that they are failure-proof, they have increased performance. And for this, we have to know these materials in their internal as well. We say it's the microstructure which controls the properties. And that's what we're interested in, developing, characterizing the microstructure of these materials. In our microscopes, we can look at these materials at a magnification of up to 1 million times. So remember, a hair which you can just see with your human eyes in our electron microscopes at 1 million times magnification is as wide as a soccer field, football field, 60 meters. Now the details which we are looking at, these atomic structures, they are as small as if you put some hairs on this whole soccer field. A hair in the wrong place on this whole soccer field can already lead to a failure, and we check every leaf of grass, every hair in these specific locations, for example, interfaces in these materials. We can see each atom individually. In a crystal, we can see each atomic column. And this was not the case 20 years ago and after the invention of the electron microscope. So this was a real breakthrough for us, for our world, and obviously also for the results which we were able to give to our collaborators. We are explorers every day, and this is the nice thing if you work in science, if you work in research at a university, that you feel yourself like an explorer every day. And you know, the fascinating thing is we have interaction with many other institutes, universities, companies. And they bring their pieces of materials, their devices, and they have certain ideas what is inside these materials. And then you look in these materials and you discover that they're actually things which they haven't even thought of. Things which are good, maybe things which are bad, which they have to change. So this is really the fascination of our job. We're discovering new things almost every day. Green energy, renewable energies are really the major topic, the major challenge for our society in the next couple of years, in the next decades. We have to come away from these fossil power sources. We have to use sources which are abundant. For example, the light of the sun is an abundant energy source. We use these photovoltaic cells. We also use wind energy. And actually, in our facility, we are also involved in the development of such energies. But it doesn't help because these energy sources, like the sun, only operate during the day, and we have to find some storage solutions.